Use calculus to find the location and nature of the stationary points of the function. The function is y equals x cubed minus x squared minus 32x minus 60. Alright. Now, you know that. Alright, by the way, before we start it, I want you to pause the video and try it. So go ahead. Alright, you finished? What did you get? Anyway, let's look at it. We know that what we are going to have to do is find the gradient function, because we know that the stationary points would be the points where the gradient is 0. So we find the gradient function and then equate the gradient function to 0. Then after that, we find out exactly where the gradient function, where the stationary points are located. Because wherever the gradient is 0, those are where the stationary points are located. Now, this will give you a cubic curve, it's a cubic graph, so it might stay like this. And in this case, the gradient would be 0 here and here, right? The turning point, the stationary points. So it would be 0 at the top of this hill and 0 at the bottom of this valley, right? Now, that means when you draw tangents to the curve, they would be horizontal lines. And the gradient of a horizontal line is 0. Anyway, let's see what happens here now. We have y equals x cubed minus x squared minus 32x minus 60. We find the gradient function. So we differentiate. We say dy by dx equals. So we're finding the rate at which y is changing with respect to x, dy by dx. We have 3x squared minus, this would be 2x minus 32. Remember the power rule, multiply by the whole power, then subtract 1 from the whole power to get the new power. Alright? Now this is a gradient function. We want to know where it is equal to 0. So we say 3x squared minus 2x minus 32 equals 0. So the gradient function is quadratic. Let's see something here now. This is a quadratic equation. What we can do is solving it, right? We could find the we could use the quadratic formula to work it out. Alright? Remember, 4 ways you can solve quadratic equations. You could use a formula, you could use completing the square, you could use graph, or factorization. Let's use a formula. It would be x equals negative b. In this case, b is negative 2, so it's negative 2, plus or minus the square root of b squared, which is negative 2 squared, minus 4 times a. The number that multiplies x squared is a, so it is 3, times c, which is negative 32, all over 2a, is 2 by 3. In this case, what do we get? 2 plus and minus the square root of 2 squared is 4. We have a minus and then a minus again, so that's going to be a plus. Plus 4 by 3 is 12. What is 12 by 32? 12 by 32 equal 384. We have 384 over 2 by 3 is 6. Alright? 236. So x equals 2 plus and minus. We have the square root of, it would be 384 plus 4, which is 388. We're finding the square root of 388 here. So we're going to find the square root of 388 equal 19.698. We're keeping to 3 decimal places until we finish. 19.698. So what we have is 19.698 over 6. So x is equal to 2 plus in one case and then 2 minus in the other case. So let's just work out what x would be equal to. So in one case we have 2 plus 19.698, we'll put in bracket here, and that will be over 6 equal 3.62, and x is also equal to, let us see what this is going to be. So in the other case it's minus. So it's negative 2.95. Negative 2.95. Alright, so those are the x values where the stationary points are. But since they ask us for the location, let us find the y values as well. What is y when x equals 3.62? So at x equals 3.62, y equals, it will be 3.62 cube, 3.62 cube minus 3.62 squared minus 32x minus 60 would be 32 by 3.62 minus 60. So what is y? Let's work this out and see what we get. So we have 3.62 cube uh, 3.62 raised. Alright, instead of raised to the power, let's just have 3.62 times 3.62 times 3 times 3.62, that's 3.62 cube, minus 3.62 squared equal, we have that, minus 32 by 3.62 equals that, minus 60 equal 141.5. 141.5. Alright. So we're looking at 3.62, 141.5 as one of the locations. Where the other is the other location. So at negative 2.95. So at x equals negative 2.95, y equals, so do negative 2.95 cube minus negative 2.95, so it's minus negative 2.95 squared minus 32 by negative 2.95 minus 60 equals. So let's work this one out and see what we get. 2.95 times 2.95 times 2.95 gives us that, and it's a minus. It's a negative. All right. Minus 2.95 squared is going to be positive when you square the negative. It's 2.95 squared is that. All right. It's going to be plus 32 by 2.95 equals minus 60 equal just about 0. Let's call it 0. So the other point is located at negative 2.95, 0. So we have the two locations here. Now, we want the nature of the stationary point. To get the nature of the stationary point, let us differentiate again. D squared y by dx squared equals dy by dx is 3x squared minus 2x minus 32. So d squared by dx squared would be 6x minus 2. It's 6x minus 2 that you would get. So it's 6x minus 2. All right. Now, when x equals 3.62, when x equals 3.62, d squared y by dx squared is equal to 6 by 3.62 minus 2. By the way, remember, if the double derivative gives a positive value, then you're looking at a minimum point. If it gives a negative value, you're looking at a maximum point. So it is, if it is negative, it's a maximum point. All right. What does this give? Well, you don't even have to complete the calculation. You can see this will be positive. But let's complete the calculation just the same. So would have 6 by 3.62. Let's see something here. So we have 6 by 3.62 equal that minus 2, 19.72. 19.72. So we have a minimum point at this point. So this is minimum. And then here, when x is negative 2.95, d squared y by dx squared would give us 6 by negative 2.95 minus 2. You can see this is definitely going to be a negative, which is a maximum point, but let us still, for the sake of practice, work it out. So we have 6 times negative 2.95 equal minus 2 equals negative 19.7 negative 19.7. You can see it's a maximum point. So this is maximum. Let's see something here. Suppose we open our graph plotter, GeoGebra, to see what the graph would look like. What we have here. What was the original function again? X cubed minus x squared minus 32x. See, let me kind of set up this thing. So we have x raised to the power of 3 minus x raised to the power of 2. So that's x cubed minus x squared minus 32x minus 60. So we have minus 32x minus 60. Alright, so what do we get? Let's kind of set up the curve, make it thicker. Now, we have one stationary point at 3.62, 141.5. Was it a positive or a negative? Why does this look like this? Let me see something. Why do I have a positive here? And these are so many negative. I suspect it's going to be a negative, you know. Maybe I left off the negative from it. Because why would the number look so negative? Let me see something here. 3.62 raised to the power of 3 equal. It's 47 point that minus 3.62 squared minus 32 by 3.62 minus 60. It's definitely negative. It's negative 141.5 something. I left off the negative. So it should be a negative value. So 3.62 and negative 141.5 minimum. Let's see something here. 3.62 negative 141.5 minimum point. So 3.62. Oh, it's gone way down, man. Let's zoom out and see where this curve goes. Alright, you can see it's close to 142, 141.5. Alright, good, exactly at 141.5. And it should be at 3.62. You can see it's a minimum point, right? But the 3.62, is it really within this area? Should be between these two lines. Let's go back up to the x-axis and see where this takes us. Right within this area should be 3.62. So we see that 3.62. The next one is what? Is a maximum point at negative 2.950. So we see negative 2.950 and its maximum point, you can see that. So negative 2. I had said 0 because it was close to 0. You can see tiny bit above 0. What was it again? It's a tiny bit above 0. I remember that happened. but I equate it to just about 0 because it's so near. And then it's a maximum point. Alright? So there you have it. I said it's a tiny bit above 0. Let's quickly calculate it again and see exactly what it was. Because you can see it's a little bit above 0. Let me see something. 2.95 raised to the power of 3 equals, and you have a negative, and then minus 2.95 squared plus 32 by 2.95 minus 60 equals 0.025 something. Alright, let's put it at the 0.025. 0.025. So it would be 0.025. Alright. So you can see on the graph it climbs. There's a little bit above that. Alright, so there you have that. So we have the location and the nature of the stationary points, and we also confirmed it by drawing, by having the computer sketch or draw the graph of the function.